Hi everyone, today I am going to discuss about Java 8 features. Okay, so before that, please subscribe my channel, like and share. Okay, so let's start. So I am going to cover 4 important Java 8 features. Okay, Lambda expression, functional interface, default methods, and stream API. So let's start with the lambda expression. So before that one, so I will wanted to discuss about anonymous class. So what is anonymous class? So the anonymous means like something you don't have any name for that class. Okay, so why we are using anonymous class? Let's take an example, anonymous class. So we have a interface called greeting, and with the abstract method greet we want to provide a implementation of greet method, right? So for that one, to provide any implementation, right, we want to create a class, separate class, right? So suppose it is we want to provide an implementation of greet method in a class, and the implementation is very minimal, and we don't have much implementation, much lines of code to be written in that method. Why it is also one time use, not many times used, right? So in that case, why we have to create a separate class to provide a implementation? It is not having a 100 lines of or 1000 lines of code or more methods in it to implement, right? So we have to create a new class. So that is implemented using a anonymous class. If you can see here how anonymous class is created. So it is returning a instance of greeting interface. Okay, so there is no name of the class, there is, right? So here it is overriding the greet method and providing a implementation, something like it is printing system out println hello from anonymous class. Okay, so to this is one time use, and we don't have to create any object of any class. We don't have to create any class, separate class, Java class file, right? So in many situations we use anonymous class to reduce, like creating a new class for implementing a one time use of a method. Okay, so in such situation we were using a anonymous class. Okay, so using anonymous instance we call that method and we provide this implementation here. Okay, so this is anonymous class. So let's come to lambda expression. Lambda expression is a provide a implementation of a such a method which is like more readable, very easy way to implement, and which reduces the boilerplate of code. If you can see here, anonymous class, it is having more lines of code, like you can see here 5 to 6 lines of code, right, to implement a this greet method. Okay, so if it is in 2 lines of code, how it will be easy, right? It will be reducing lines of code, right? So that can be done using a lambda expression. Okay, so let me show you another class. So you can see here, using a anonymous class we have implemented operate method, and using a lambda expression we have implemented operate method. Okay, you can see here, using lambda expression it is only 2 lines of code, but with anonymous class it is having 4 to 5 lines of code, right? So how much it is easy with the lambda expression, and how much it is readable, like it is reducing boilerplate of code, right, to provide a implementation of a particular operate method. Okay. So that is why we came up with this solution, I mean to say, like this lambda expression, which is providing a implementation of a method with a easier way. So let's understand how the lambda expressions are created to provide a implementation. Okay. So this is returning a, you know, instance result of a particular interface. Okay. We have to create a result of particular that interface for which we are, you know, particular method, abstract method we are going to implement using a lambda expression. Okay. So here you can see this part, it is having open close bracket where it is taking two parameters. This is the same, you know, syntax where this method is having two parameters taking int a, int b to, you know, perform any operation, like we are operating addition or subtraction. We can provide any kind of implementation, right. So here also the first thing is, first part of the lambda expression is open close bracket where it is passing two parameters, that is the number of parameters and type of parameters this method, abstract method, for the interface we are going to implement. Okay. After that it has a part like arrow mark. Okay. So arrow mark, after that we can see a minus b, this is the implementation part. Okay. So here we can add any lines of code. Okay. So this is the implementation part, we are performing a minus b in case of subtraction. In case of addition we provide a plus b. Okay. Suppose if it is a instead of subtraction, if it is a multiplication, we provide a star b. If it is a division, a divided b. Okay. So that depends upon what are going to implement. Okay. If it is a if it is a more lines of code, right, so we, you know, enclose this in a, you know, flavor bracket. Okay. So that one I will show you later. So now a minus p, so which is a subtraction of two integers. Okay. Let me take you explain you another with another method. Suppose instead of operate method, okay, I have a print method. This is without any parameters. Okay. So let's comment this one. Suppose this interface has void print, it is not taking any parameters. So how do I implement this one? Okay, using a lambda expression. So first of all we have to create a instance returning the same as, you know, interface. So we have to return math operation and I am saying it as a print instance. Okay. Now we have to have a open and close bracket. So here it is not taking any parameters, right. So I am not going to send any parameters inside this one. Then arrow mark, then you have to provide a implementation. Okay. So I am just going to implement saying printing hello lambda. So now we have to call that method, right, using a instance. So we have to use this instance to call that print method. So it will print hello lambda. You can see here hello lambda is printed. Okay. So this is how you can use a lambda expression to provide a implementation. So there are, suppose there can be any method, whatever method, so that should match here whatever we are taking. So this is how we can provide a lambda expression implementation. So let me take you through another Java interface. Okay. Functional interface. So what is functional interface? Interface having a single method, and it can have a default or static methods. Okay. So that is called as a functional interface. The main purpose of functional interface is like functional programming. So which provide a functional way of implementing particular method in of a interface. Okay. So lambda expression is used to provide a implementation of functional interface method. Okay. Let me give you example. So here you can see here a functional interface annotated with @functional interface. So my functional interface is the interface name, and it is annotated with a functional @functional interface, which is having a abstract method called my method. Okay. So if you don't add the annotation also, okay, but it should have only one method. So why we are adding this annotation? Because suppose if somebody added another, say another method, say print hello. Okay. So here you can see here this is giving error, because a functional interface can have only one abstract method. It cannot have any no more than one abstract method. It can have default method, say default print hello. Okay. So it's, we have to provide some implementation. Okay. Say so here we have a default method, right. So in the functional interface we can have any number of default method, we can have a static method also. Okay. But we cannot have more than one abstract method. So otherwise it will give a error. That is why we are adding a annotation called functional interface, which ensure that this functional interface will have only one abstract method. Okay. So let's come to implementation. So using anonymous class, we are providing a implementation like this. Okay. So it is return type is my functional interface, and anonymous we are calling a my method which is providing a system out dot println. So allow from anonymous class. Okay. So using a lambda expression, how we are implementing here. So it is returning a my functional interface with the lambda instance, and which is not taking any input parameters. So we are not passing any input parameters, which is providing a implementation like printing system out dot println hello from lambda, and we are calling a lambda dot my method. Okay, using this instance. Okay. So this is how we use a lambda expression to provide a implementation of functional interface. Okay. We mainly use lambda expression for the implementation of any implementation of abstract method of functional interface. Okay. There are built in a functional interface. I will show you what are the built in functional interface we are using to provide a implementation. Okay, using a lambda expression. So first one is a consumer. Okay. So let me copy the code. So consumer is a one of the built-in functional interface which accept the input and provide a implementation. Okay. So consumer, in the name itself, it consumes something and provides some implementation. Okay. So the name is itself indicates it consumes something, and which does not return anything, but it only consumes something and provide implementation for that one. Okay. So we don't see any result, something like it will not return here you can see here it is just printing, it is not returning any response. Suppose in case of like add operation, we are taking two so here you can see here in the operate method, here it is taking two parameters to add and returning a int as a result, right. But in case of consumer, so it takes some string value and it prints that string value, it is not returning anything, it is just consuming the input parameter. Okay. So this is how we provide a consumer, it is one of the functional interface. Okay. Let us run this one. So it is printing hello. So we are passing the hello as a input parameters, which is converting it to uppercase. Okay. So I am printing that one, right. So this is how consumer is used. Okay. Consumer, one of the functional interface. Let us say take another functional interface called supplier. So represent supplier of a results producing a result without taking any input, right. Let me explain you. So what is supplier? Supplier is another functional interface which actually does not take any input, which produces something as a result. Okay, here we are producing math random is producing a number, random number, right? Okay, in which all cases we use supplier. Suppose so we want to generate a random number. Okay, in some java code, we are using some random number, and we are generating that random number using a math random function, and we are using that random number somewhere in the code, right? So for that one we just use this supplier functional interface. Using this lambda expression we generate that random number to okay, use that random number in the code. Okay, so let me run this one. Here you can see random number, it generated 0.3 something something. Okay, let me take you through another functional interface, function. So what is function? Function represents that takes one as a argument and produce the result. Okay, let me copy this. So this is the functional interface called function, so which takes string as a input and produces integer as a output. Okay, suppose let's say example like okay, so we want to find a length of a string, right? So we pass string as a example. Okay, so it will calculate the length of this example, and the length is returned as a integer. Okay, so these kind of examples or like applications we can use function as a functional interface. Let me run this one. So length of example string is 7, it is printing. Okay, so whatever like it, you can pass an input something string or integer or anything, so that will should give a result something. Okay, it will take one parameter as a input and return as a another parameter. So okay, let me explain you with another example. Okay, so suppose if you want to no okay, convert integer into a no integer into string into a not string. Okay, so you want to find a uppercase of a string. Okay, so it takes string as a input and return string as a output. Okay, so here function I can see I can provide like uppercase. Okay, uppercase function, so it is taking string as a input and giving the result as a string, that is uppercase of that string. So uppercase dot apply, I am passing a example as a string. Okay, so it takes example as a string and it converts that string into uppercase. Okay, so let's run this one. So here you can see here in the console, uppercase of example, it convert that example into uppercase, right. So it is taking string as a input and giving the result as a string. So there are many use cases. You can use function as a functional interface, okay, using a lambda expression. I have provided you, this is one of the example. You can use many places this functional interface. Okay, this is one, like it is taking one only one parameter as a input. Okay, there are suppose like another example like function. We have to take we have seen here like you can see here like adding a two integer, right. I want to pass, suppose, so I am passing a I am passing a two integer, okay, as a input, and I am getting a result as a integer. Okay, I am naming it as a addition function. This is called as a by function because it is taking two two parameters, right. So that is why it is called as a by function. If it is taking single input parameter and giving the result one, that is, then it is called as just function. Okay, by function which will take two parameters as a input parameter and gives the result. Okay, let's try to implement this one. So let's take this example here only. So we have to import this one. Oh, sorry, let's copy this one, wrong spelling. Okay, by function dot apply. So we have to pass two parameters as a integer 5. I am adding 5 comma 6. Okay, let's copy this one. Addition of two integers. So in the by function we are passing two parameters as a integer. Okay, that is why it is called as a by. By means two, right. So it is giving as one result, that is as data type is integer. Okay, let's run this one. So it is taking 2 and a plus b giving the addition of two parameters. You can see here addition of two integers, it is printing 11, right. 5 plus 6 is equal to 11. So, this is how we use a functional interface, okay, to provide an implementation using a lambda expression. So, lambda expression is a way to implement any functional interface. Okay. So, we have seen consumer, supplier, functional interface. So, there are few other interface, functional interfaces. You can go through those things. I have given very more used, more in Java programming, most used functional interface. These are the consumer, supplier, function. These are the things most used in Java programming language. Okay. Let's discuss another feature like default method. Okay. So, what is default method? So, we have already shown you, I have shown you already in the previous example default method, right. So, why we need a default method? We before Java 8 we used to have a only abstract method in a functional in a interface, right. Why we need a default method? Okay. So, default method is providing a backward compatibility. What does it mean? Okay. So, let me explain you easily. Okay. So, let us take a example like interface, my interface. Okay. This is the one interface. So, let us take a okay, class 1. Okay. So, this interface is having a method like say operate, abstract method. Okay. So, this abstract method is implemented in class 1, class 3, class 2. Okay. So, class 1, class 2, class 3 are providing a implementation of operate method from this my interface. Okay. Suppose you want to, this is existing code in Java. Okay. So, in project we have already a my interface with operate method and 3 classes are providing a implementation of their own implementation of this operate method. Suppose if I want to introduce some other method in the interface, right, like say print method. Okay. So, if I introduce print method here in the my interface, so all these 3 classes have to provide implementation of this print method. They have to override this all 3 all 3 these classes, they have to override this print method and provide implementation, right. So, it is means we are disturbing all 3 classes. Suppose if there are 30-40 classes implementing a method from this interface, in that case, if I introduce this print method in this interface, it disturbs 30-40 classes, that we have to make changes in all 30-40 classes. That is complex, right? So disturbing 30-40 classes, making changes in those 30-40 classes, which is something disturbing, right? So to not to disturb those classes, they all those classes should not implement this thing, this print method, right? Suppose okay, let's take another class, class 10. Okay, so class 10 only has to provide implementation of this print method. Okay, it has to you use this class, I mean we have to use this print method only in this class 10. We do not want to use in all these classes. Okay, so in that case what we have is default method. So default method will provide an implementation here only. Sorry. So we provided default method implementation in the interface. So whichever class want to provide a implementation of this print, we want to use this print method. Okay, so class 1 wanted to use this print method, they will call this method. Class 10 want to use this print method, they will class this print method. If class 2 don't want to use this print method, they will not class. This will not disturb any other classes, right? This is called as a backward compatibility. It will not disturb when you introduce something into interface. No, it will not disturb any other classes which are providing a implementation of this my interface. Okay, so whatever class want to use this method, they will class they will call this method directly. So class 10 is wanted to implement use this print method, so it will call this method, default method. So I will show you how so functional interface, how we have to implement that default method. Okay, so let's create a separate method, separate interface. So this is one interface where I am providing a default method. Okay, so here I am implementing something. Okay, so if this my interface is used implemented by so 10 classes. Okay, so they can call this default method and they can use that in their classes. If they don't want, they will not call this method. if there is any abstract method here, right, they have to provide the implementation of those things, they have to override those methods, right. If I introduce any abstract method in this interface, they definitely have to override. It will disturb all the classes which are implementing this interface. I do not want to disturb all those classes, right. So, that is why I have a method called default method. So, let us discuss stream API. So, stream API is the one of the best Java 8 feature which is most widely used in Java programming, which is dealing with collections. So, let me explain you with the code. So, stream API which supports parallel processing allows operations like filter, map, reduce, so many things. So, let me okay. So, let us say so, I have a array list, okay. So, which is having a list of strings A, B, C, okay. So, I want to iterate this list of strings, and here I have a 3 functionalities, 3 operations I am doing in a stream API, that is filter, map, for each. So, filter, what is filter? Filter will filter all the incoming input. So, I have a my list as a string list of strings, and I am, if it is a starting with A, then only I am filtering those strings, and then what I am doing, I am converting that to uppercase using a map. Map is a operation which used to transform particular input, okay. So, I am transforming that A to uppercase, okay. Then using a for each, I am printing those whatever result. Let me run this one. You can see here it is printing A, okay. So, what it is doing? It is iterating, it is this list of strings, and it is checking starting with A, which are all strings are starting with A. So, this is the one string which is starting with A. So, it is taking that one and passing to map operation. So, what map operation is doing? It is converting it to, transforming it to uppercase. So, when we convert small into uppercase, it will become caps A, right. Then for each, it is sending to for each. For each, what it is doing? It is printing that but whatever map is passing to it, okay. Let us say I will give you some other example, okay. Okay, list of, I will take a list of cars. So car name I am taking Mercedes, Tata, Innova. Okay. So using a stream, I want to filter a car name which is equal to Tata function. Okay. Stream dot filter. So S equal Tata dot sorry. So in this case what I am doing, I am iterating the list of cars using a stream and filtering those cars. If it is equal to Tata, then only I am printing. Okay. Let me run this one. See, you can see it is printing Tata. So you can use multiple operations with a stream. Stream has a filter, map, for each, any there are so many operations used you can you know use with stream. Stream works with collection of entity. So it can be list of strings, list of integers, list of objects. So if you suppose if you have a collection of employees and you want to uh, you know you know filter employees whose salary is greater than 10,000. So you can use a stream and filter where you can apply filter such that collection the employee salary greater than 10,000, and then you can print those things. And you can use a collect to also, it returns the result. Okay. So this is what stream API. So we have covered 4 important Java 8 features: lambda expression, functional interface, default methods, and stream API. So their users, what are the they users in real time application, right? Okay. Thank you so much. Please put a comment if you need for any more any kind of explanation or any help. So you can put a comment in the video. Okay. Thank you so much.